High above the earth, in a region of the sky where no missile could reach and no fighter could follow, the United States flew an aircraft that quietly reshaped the balance of power during the Cold War. While the world feared nuclear war and watched superpowers threaten one another with weapons capable of ending civilization, American engineers pursued a different form of dominance. They did not seek destruction, they sought inevitability. They built an aircraft that could go anywhere, see everything, and leave without permission. This aircraft did not need to fight. Its very existence was enough. This was the SR-71 Blackbird. To understand why the SR-71 terrified the Soviet Union, one must understand the world it was born into. The Cold War was not a conflict of open battles, but of constant tension, secrecy, and mistrust. Both sides believed that the next war would be decided not by armies, but by information. Knowing where missiles were hidden, where bombers were based, and how quickly an enemy could respond meant the difference between survival and annihilation. Intelligence was power, and the United States was determined to gather it at any cost. Before the Blackbird, reconnaissance flights were dangerous and uncertain. Pilots flew modified aircraft deep into hostile airspace, often at subsonic speeds in limited altitudes. Some missions succeeded, others ended in disaster. Aircraft were shot down, pilots were captured, political crises erupted. The United States needed a solution that removed risk, not through stealth or negotiation, but through physics itself. If an aircraft could fly faster than anything else in the sky and higher than anything could reach, interception would become impossible. That idea became the foundation of the SR-71. When the Blackbird began flying operational missions, Soviet radar operators were the first to encounter its presence. On their screens appeared a target unlike anything they had seen before. It was moving at extreme speed, at an altitude that placed it beyond the effective range of most air defense systems. At first, confusion dominated. Equipment was recalibrated. Operators questioned their instruments. But the signatures kept appearing, again and again, following predictable routes across sensitive regions of Soviet territory. The conclusion was unavoidable. The United States was flying freely through their airspace. Each detection triggered a chain reaction throughout the Soviet defense network. Command centers issued alerts, interceptor squadrons were scrambled with urgency, missile batteries prepared for launch, pilots pushed their aircraft to the absolute limits of performance. Yet despite every effort, the outcome never changed. The Blackbird remained unreachable. It did not maneuver aggressively, it did not descend, it simply maintained its course, indifferent to the chaos unfolding below. Soviet pilots later described the experience as deeply unsettling. They were trained to intercept, to engage, to defend. Against the SR-71, they could do none of these things. The reason lay in the aircraft's extraordinary performance. Flying above 85,000 feet and exceeding Mach 3, the aircraft operated in a region of the atmosphere where air was thin and unforgiving. Interceptor aircraft struggled to climb high enough before exhausting their engines. Missiles launched from the ground faced similar limitations. By the time they reached the Blackbird's altitude, it had already accelerated beyond their engagement window. Even when missiles detonated nearby, the aircraft's speed and distance rendered them ineffective. The SR-71 did not evade threats, it outran them. But speed alone does not explain the Blackbird's dominance. The aircraft was a masterpiece of engineering born from necessity. At sustained Mach 3 flight, friction with the atmosphere generated extreme heat across the airframe. Conventional materials could not survive these conditions. To solve this, American engineers turned to titanium, a metal that offered both strength and heat resistance. At the time, the United States did not produce titanium in sufficient quantities. In one of the great ironies of the Cold War, much of the titanium used in the SR-71 was quietly sourced from suppliers connected to the Soviet Union itself without their knowledge of its final purpose. The aircraft was designed around this reality. On the ground, the SR-71 leaked fuel from its tanks because its panels had not yet expanded. Only once airborne and at speed did the structure seal properly. The aircraft was not meant to be comfortable or forgiving. It was meant to function at the edge of what was physically possible. Even its engines defied traditional classification. At lower speeds, they behaved like turbojets. As speed increased, they transitioned into a system that relied heavily on ram compression, turning the entire engine into a high-speed airflow machine. This hybrid design allowed the SR-71 to operate efficiently at velocities no other aircraft could sustain. For Soviet engineers and planners, the Blackbird represented a technological gap that could not be closed quickly. Every successful mission confirmed that American aerospace design had leaped far ahead. Entire air defense doctrines were called into question. New interceptor programs were launched. Missile systems were redesigned. Radar networks were expanded and modernized. Billions were spent chasing a solution that remained just out of reach. Over the years, more than 4,000 missiles were fired in attempts to intercept the SR-71. Not one achieved a kill. Each failure reinforced the aircraft's myth-like status. Beyond its technical impact, the SR-71 exerted enormous psychological pressure. In the Cold War, perception mattered as much as capability. Knowing that American aircraft could enter Soviet airspace at will, gather intelligence on the most sensitive installations, and leave without consequence, created a constant sense of vulnerability. Soviet commanders had to assume that their missile sites, bomber bases, and radar stations were already known. This uncertainty shaped strategic decisions and forced costly countermeasures. The Blackbird turned reconnaissance into a form of silent intimidation. Despite its power, the SR-71 remained unarmed. It never dropped bombs or fired missiles. Its influence came entirely from what it represented. It was proof that American engineers could solve problems others could not, build machines others could not imagine, and operate in environments others could not reach. In a conflict defined by restraint, the SR-71 demonstrated that superiority did not always require confrontation. Sometimes, it only required presence. When the SR-71 was finally retired, it left behind a legacy unmatched in aviation history. No aircraft has surpassed its operational speed or altitude. No reconnaissance platform has achieved the same combination of survivability and effectiveness. The Blackbird remains a symbol of a moment when American engineering reached beyond known limits and succeeded. In the Cold War, the SR-71 did not win battles. It won something far more important. It proved that there were places the United States could go where no one else could follow.